ahead and do that. Okay, so we are going to be prepping for our final exam here. And let me go ahead. I'm going to keep notes on problems I really like. And problem number one is a problem I really like, although I will warn you that the problem I actually like to give is this problem, right? Oh, there's my little pad to write on. There we go. Is this little problem here, but I'll usually phrase it a little bit differently. So that I would rather phrase it this way. I would say, given the hard to remember that this thing has an upside and a downside. Okay, given the points, whatever they happen to be, okay, and -8, 9. As the opposite points on a circle, determine the center of the circle, okay, the radius, and write the equation in standard form. Right, and this is the kind of way I would write it. Okay? Given these points as the opposite sides of a circle, okay, determine the center, determine the radius, and write the equation in standard form, comma, because I really try to minimize the number of formulas you guys have to write. So I would put that in there so that you would be reminded of standard form and you wouldn't have to like memorize what that was. You have to know what the h is, you have to know the k is, and you have to know that the radius gets squared. Okay, but I'm not trying to say you have to remember, because this is not going to come up in your life very well. Actually, it does. Circles come up quite often, so being able to recognize them is good. But you'll have pre-calculus next semester, and you'll be able to. They'll quiz you again on this all over again, except we add to it and we do ellipses. Okay. Okay, so what is the distance between the points? What's the midpoint? Because the distance and the midpoint are contained within this question, which is why I would rather like to ask it this way, because it gets more things done. So I'm going to go ahead and type in this and say, you're going to have a circle problem. Okay. So let me go ahead and graph this first. And this is -2 and -8, 9. So most of this is happening in the second quadrant. So we'll go ahead and do that. Okay. And we've got to do what? We've got to do -9, 2. So 1, 2, 3, 4, 5. 2, 3, 4, 5. So there's 9 and 1, 2. So there's 1 point. Okay. Then they have -8, and then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we're going to go -8 and then 9. Okay, so there's my circle. Now, you can memorize the midpoint and you can memorize the distance formula if you'd like. I don't like to do either of those things. So here's what I'd like to do. Right, we're going to try to figure this out. And we're going to need some kind of a diameter here. It seems like it's halfway between, right, -8 and -9. Okay, and then the distance up on top here, right, that's halfway between 2 and 9 up here. Okay, and that really is what the midpoint is. Okay, all they're telling you to do is average the two ordinates. So my midpoint, or the center of my circle, okay, that's going to be -8 plus -9 divided by 2. Okay, so that's going to be, right, -8, 8.5, so -17.5. Okay. The y part Okay, the y part is going to be halfway between 2 and 9. So 2 plus 9 divided by 2, that's halfway between them. So that's going to be 11 halves, okay, or 5.5. Okay, and if you draw a better picture, right, it's actually not too terrible, but there we go with that. The other thing that I want to do is I will need to figure out the distance between them. Let's use that one, okay. So the distance between them, and again, you can memorize the distance formula if you really want to, but what the distance formula, all the distance formula is, it's the hypotenuse of this triangle. Okay, so all you have to do is figure out what this is. I have to figure out what this side is, and then we're just going to get our c squared here. Okay, so how much is this distance here? Right, it goes from -8 to -9. Well, that's right, -9. Well, it's -8 minus a -9, isn't it? Right, the bigger one minus the smaller one. I'd rather be $8 in debt than $9 in debt. So we're going to have -8 minus a -9. This equal to 1. Okay. So this distance here is 1. Okay. And there's plenty of ways of figuring that out. Okay. And then we have to figure this distance out, right? This is at 2, this is at 9. What's the distance between 2 and 9? Okay. Isn't that 9 minus 2? So that distance would be 7. 5 there. So this distance here is going to be 7. Now all we have to do is apply Pythagorean distance, right? Pythagorean's theorem, and then we're going to have the rest of that. So we're going to have 7 squared plus 1 squared, square rooted. That's equal to my c squared. C squared is equal to square root of 7 squared is 49 plus 1. C squared is equal to the square root of 50. Okay, that's 25 times 2, right? So C is equal to, right, the square root of 25 times the square root of 2. That's 5 root 2. However, this is not the answer I want, because this is going to tell me the whole thing. And if I told you that this whole thing is the circle, right, how much of that is the radius? And you would say half of that. Okay, so the radius is equal to 5 square root of 2 over 2, right? Or square root of 50, right? Over 2. That's my radius. Okay. So great. We've got the distance, right, which is what they asked for at the beginning. Find the, no, we don't need that. Find the distance, find the midpoint. And all we're going to do now is figure out the equation of a circle. So we'll go back to blue. Okay. And that was x minus the horizontal part squared plus y minus the vertical part. And that is equal to r squared. Okay. So we're going to have x minus, what was the horizontal part? It was 17 halves. So minus a negative 17 halves squared, which you're not going to write that. You're going to do that for me, right? You're not going to minus a minus. You're going to just plus it. Plus y minus. And what was this? This was 5.5, wasn't it? So that's 11 halves, wasn't it? Squared. And that's equal to, and then we have to do this. We have to take 50 over 2 squared. Square root of 50 times square root of 50 is 50 divided by 4. And we're not going to mess with it. Okay, they just said find it in standard form. They didn't say find it in standard form and then make it prettier. They didn't say any of that. They just said put it in standard form. There you go. That's it. Okay. So I often ask that question on a final. So that's one I would definitely be ready for. I can't promise the numbers are going to be better or worse than this, but on a final exam, I really do try to find numbers that work better than, better than most. Okay, so there should be easier numbers. Hopefully I will come up with ones that are not quite as many fractions. Okay, and then we'll go with that. Maybe we could do this. Okay, 20 over 2, 25 over 2. Okay, but that's our values there. Okay, so that was a good problem. Okay, let's see here. Let's do this one for reinforcement. Okay, I'm probably not. Actually, I don't know what I'm going to do with this. Okay, so my goal right now is to give you about 9 to 12 problems where you break them out, and then I'll grade them on that way. Yeah, I think that's what I'm going to have to do. So I didn't prep you guys to do any other way. So this is going to be, right, x minus h squared plus y minus k squared equals r squared. And again, the way I'm going to ask this is, given a circle with center -2, radius -3, and radius 1, I'm going to say, write it in standard form, comma, x minus h squared plus y minus k squared is equal to r squared. Okay, so I'm not, again, trying not to give you too many formulas you have to memorize, because I don't like doing that. So this is going to be x minus -2 squared, y minus -3 squared equals 1 squared. We're going to clean this up a little bit, because I know they said standard form, but we're going to make that better. Right? So there is our values. Okay, so let's go ahead and write that in. We're going to have x plus 2 squared. Come on. Plus, what is this? Y plus 3. You have to remember the right-hand side. I did this quite often in my pre-calc class, was I forgot to write down the right-hand side equal to 1, because there's a lot of other ones that are just equal to 1. So be careful about that. Although it's a human being grading it when you're doing this, so it's not going to be the worst thing in the world. But let's see here. Let's try like the circle. So let's go with -2, -3, and we'll do 1 point over. Oops, what did I do? No, I don't want an oval. I want -2, -3. And we're just going to, oops, 2. There's my center. Just going to go 1 point over. And then, oh. They don't tell you. Okay, that's delightful. Okay. I'm going to go ahead and skip this problem, mostly because we have a parabola and it asks us for x and y intercepts, and we're going to ask that question over here when we get to parabolas. Okay, that's like a chapter 2 problem. Right now, they're making it a chapter 1 problem. I don't want to make you do a chapter 1 problem, but I've got a chapter 2 problem up my sleeve. Okay, good Lord. Yeah, we're not doing that. Do we need to do a problem like this? All right, I don't know if we need to do a problem like this. First off, this is perfectly fine line the way it's written. You could do this. Oops, 2x equals, what am I doing? Okay, 2x equals 4 plus 8. We could say divide everybody and end up with something like that. Okay, and now we're just going to solve for y. Okay, this is the kind of problem where it's like, I should ask it on a final exam, but I don't know if I will. It seems like it's one of those problems where it's like, I don't want to ask it because it seems like it's too easy. Okay. So I guess that's a warning. Like if it seems like if if I'm looking at it like this is too easy, now this practice some lines. It will, being able to be good at lines really does help out in a number of different classes. You will use this again. Okay, the y-intercept, right? 0, 4. Okay, and then equation written in slope form. There it is. Okay, they're not going to grade me, so I'm not going to worry about trying to please the algorithm here. Okay, tell you what, we're going to do this one because this was part of our problems. Remember doing this. We're going to give in the 2 points, make a line, save. Okay, so this is one of those problems where I think everybody should be able to do this. Again, it's going to come in real handy if you're doing chemistry lab, if you're doing biology lab. There's going to be times where you're going to take measurements and you're going to have 2 of them. You're going to say, well, what's the rate of change between these 2 points? What's the slope between these 2 points? Okay, so here we go. We have 4, 3, and 1, 5. Now, there's a variety of ways to choose to solve this. I don't really care which way you use. Okay, as long as you can take 2 points and turn them into a line, I'm really happy with you. Okay, so I'll go over both of the methods here. Okay, so the first thing we're going to do, no matter which method you use, the first thing you got to do is we got to find our slope. Right, and that's the change in y over the change in x, y2 minus y1, x2 minus x1. Okay, it's a Greek delta. Okay, your science books write it this way. Your math books somehow decided that this was too hard. So biology is like, yeah, fine, delta y over delta x. That's the way we do it. Algebra book, no, that's too hard. We're not going to write it. We're going to write it this way now. As long as you keep your x's and your y's straight, you are not going to get this problem wrong. Okay. So all we're going to do is we're going to take the difference in the y's, right? That's the rise. So we're going to have 5 minus 3 over 1 minus 4. So we pick this one to be 0.2. So we have the 5 minus the first y, second x minus the first x. Okay. It doesn't matter which way you do. Okay. If I chose it the other way around, we would get 3 minus 5 over 4 minus 1. Either way, right, we're getting a 2 on the top and a minus 3 on the bottom. In this case, we're getting a minus 2 on the top, put a positive 3 on the bottom. So our slope is negative 2/3. Doesn't matter if you put the negative upstairs, downstairs, or in the middle. Okay, doesn't matter. So that's my m, that's my slope. Okay, now the way I would love to see you solve this problem next is to do something like this. But that is not the only way. Okay, we could also go straight to y equals mx plus b and work it that way. So I'm going to kind of do them side by side here. Okay, this one, pick your favorite points. Okay, doesn't really matter which one you pick. I'm going to pick 4, 3. Okay, so we're just going to fill this in. Y minus the y that you picked equals negative 2/3, parentheses, don't forget the parentheses, x minus 4. Okay. Here we're just going to plug in the y value. Okay, the y value was 3. We have negative 2/3. What's my x value? 4 plus b. And we're going to solve for b. So here we have y minus 3 is equal to negative 2/3 x plus 2 times 4 is 8/3. Okay. I'm going to go out on a limb and call this 9/3 here. Okay. So here we have 3, or 9/3, is equal to negative 8/3 plus b. Okay. So here we're going to go ahead and subtract 9/3 from both sides. Oh no, we're going to add. Sorry, we're going to add 9/3 because we have a minus minus. We're going to add 9/3. Okay. Here we're going to add 8/3 to both sides. Okay. So these cancel for here, right? So we just have y equals negative 2/3 x, 8 plus 9, both thirds. So 8/3 and 9/3, that's going to be 17/3. Okay. Over here, we're going to have b is equal. We have 3 plus 8/3. So we're going to say, oh, 3/3, or 3 is really 9/3, 9 plus 8, 17/3. We'll go back and we'll say that's negative 2/3 x plus 17/3. So same effort, really. Okay, same result. Pick your favorite one. Okay. During the class, we made you practice both of these, I think. Okay. Now, when we do final exam, I want you to find one that you like and do it that way. Okay. Either one is good. All right. So let's see here. 7 park garage, flat fee. Again, that seems a little on the easy side. Oh, this is one thing I do really miss the way that you can do this on Connect that you can't do on paper. Okay, I really do miss this. So here's my square root function. What's the 3 and the 5 doing? Okay, well, the 5 is a vertical shift, right? So we have to go downstairs 5. We have to do 1, 2, 3. I'll pick it up. 2, 3, 4, 5. Okay, and then this plus 3 is going to move it to the left, right? It's going to move it to the left 3 units. One, 2, 3. All right. Oh, I was expecting it to grade it. It didn't. All right, but that's what you do with these, and I really do wish we had a better format for this on hand, but we don't. So we're kind of stuck with this. Okay. This is about the right difficulty for a final exam. It doesn't have to have every element in here with a reflection or everything else. This will probably be an ABC kind of a problem though. So I'll probably ask a couple of them. Again, we're not going to be doing, not going to, the point is not to pile on the number of elements here. All right, we'll come back to some of those. Okay, so this one, okay. Average rate of change. Okay, I'm just going to let you know, the better you get good at doing these, the easier your future math problems will be. I probably won't go through this A part. I'll probably just find the average rate of change and simplify, or find the difference quotient. That's what this is called. But the way I'm going to say is find the difference quotient or determine the difference quotient. I'll look find. Comma. There. And simplify. So even the pre-calculus class I'm teaching, I gave them this formula. I will give you this formula. You do not have to, if I say find the difference quotient, it'll be sitting right there next to the problem. Don't go through and memorize this. This is, again, about the right difficulty for a final exam for you guys. So this is pretty much spot on. Okay. So we're going to have f of x is equal to x squared plus 6x. Okay. So to do this, right, f of x plus h, we're going to say this is x plus h squared plus 6x plus h. Everywhere we see an x, we're going to replace it with x plus h. So what I want to go through and do f of x plus h minus f of x all over h. By the way, the goal here, how do you know you have the right answer? Or how do you know you're done? When you've canceled that h, you're done. Okay, that's how you know. So we're going to say this is going to be x squared plus 2xh plus h squared. And that's multiplying that out. Plus 6x plus 6h minus, and we have to do x squared plus 6x here. Okay, distribute the negative sign to both terms. Okay, this is, if you got this far, this is your next mistake. Okay, so you got this one, and then you fail to get this one. Okay, so that is your next big mistake. So we're going to say this is going to be x squared plus 2xh plus h squared plus 6x plus 6h minus x squared minus 6x, all divided by h. Okay, now there's some stuff that cancels, isn't there? Right? This x here, one's positive, one's negative. How about a 6x? Positive 6x, there's a negative 6x. And then nothing else is going to cancel. Okay, so we're going to have 2xh plus h squared plus 6h. Those terms are gone, divided by h. Be careful not to cancel just one h. You got to do this. All right, now we cancel. Okay, you could have canceled out of all three terms. It's just that's like one of the second biggest mistakes I see students make is they cancel and then they forget to do the other ones. So be careful. But those will cancel out, and now we are left with 2x plus h plus 6. You're given an x, you're giving a step, and then we have the values of the function here. So what would happen is, wrong quadrant. Let me go ahead and change that to a better quadrant. Right, because it's x squared plus 6x, so that's x plus 6, x equals 0, x equals negative 6, right? 2, 3, 6. So here's my parabola. It's going to be 3 somewhere. Okay, pretend that goes through the origin. So what we're trying to do is this is telling us this is the slope of the secant line. So I'm going to give you an x, and I'm going to give you a step, okay, h. And the x and the h are going to give you 2 points. And we just did this, right? We said, oh, you have 2 points. Can you make a line out of those 2 points? You sure can. But what if I stepped in a different spot? What if I stepped over here? What if my h was bigger? We have x, we have h over here. Okay? We would have a different value, right? We would have x over here, we'd have h over there. Okay, and that would be my slope of the secant line. So the other big mistake that students often make with this is that they don't deal with this h on the inside very well, and they just leave it out to dry. They just say, oh, well, that's x squared plus 6x. Don't do this. This is terrible. Okay. They cancel, and they cancel, and then they cancel, and we end up with a 1. There's only one class of functions that have a slope of 1, and that looks like y equals 1x plus an intercept. That wasn't our original problem, was it? No. And I am not going to give you this problem because it's too easy. So if you get an answer of 1, you screwed up. Go back and recheck everything because this is not the answer. Okay, so just be real careful about that. Okay, there it is. Okay, be real careful. That is the single biggest mistake that students make. And I'm sorry to tell you, like that, it's worth a lot of points. Okay, because that's a mistake that's really bad. All right, so that's like automatic. You get a +2 on your problem out of 6, +1 out of 6, something like that. So don't do this. It's like automatically failing that question. And yeah, I will ask you one like that. So let me go ahead and add that to my notes. We'll do a difference quotient. It'll be a quadratic. Okay, it'll be a quadratic. Let's see here. Where are we? We're at number 10 already, aren't we? Wow. Thanks, Chief. Given functions, evaluate. These are rough. Okay, hold on. Let's see what else we have. If they gave us any other ones to do with that. Nope. Let's go back. Let's go ahead and do something like this. I feel compelled to like put one of these on here, so we'll just say function composition. If we end up with too many, this will probably be one of the first ones that I sacrifice. But just in case we'd end up with 12 on the dot, we're going to have to deal with this one. Fortunately, this one doesn't ask us to do a domain, right? They just say, well, go ahead and evaluate it. Okay, thank goodness. Okay, that's still pretty onerous, but let's go ahead and do that one. Okay, so we have h of x is equal to 7x minus 3. G of x was equal to square root of 7x. And f of x was equal to x cubed plus 9x. Okay. And they want to know x equals 7. Oh, they don't need f. Look, h and g, that's it. Okay, I will try not to be that tricky about it. I think like giving you extra information and never using it. Okay, that's fine for an accounting final because that's what they do. They give you all the information you need, and then they only use half of it. But for you guys, I think that's unnecessarily distracting. So I try not to do that for you too much. A little bit, I wouldn't have a problem. But this is already like there's too much going on. Okay, so here we go. H of x. So we have. So what the idea here is, right? We're going to evaluate g of 7. Okay, so evaluate g of 7. Now, whatever comes out, this is going to be the input for h of whatever this answer is. So I'm going to go ahead and call this answer 1. So whatever we get here, we're going to plug into h, and we're going to say, well, that's answer 1. And then we're going to get our final answer. Okay. So what's g of 7? Okay, well, fortunately, like that worked out pretty well, right? That's 7 times 7, that's the square roots. So that's 49, square root of 49 goes back to 7. Okay. So that's our output. And now what we're going to do is we're going to take this number that we got out, right, and plug it into h and say h of 7, right? And h was what was h? H was 7x minus 3. So that's 49 minus 3. If I'm not mistaken, that'll give us 46. All right. So that seems like a reasonable question to ask. Okay, it's a nice, I would say it's kind of on the easy side, but they don't all have to be the hardest question you've ever encountered. All right. This is perfect. Okay, this is a word problem with quadratic. Okay, so that's a word problem with quadratic. Okay, they give us a parabola. I actually rather like this problem because Popular Mechanics actually does this problem every year. At least they used to. That way you can know what your optimum speed is for your gas mileage. Okay, so M is the miles per gallon, X is the speed of the vehicle, miles per hour, and then we are going to figure out like what. So if you're getting low on gas, right, you're traveling to Needles from Bakersfield. Like, what speed should you be going? There are no gas stations out there. By the way, don't stop for Needles. Go across the border to Arizona. Gas is cheaper. Okay. Okay. So actually, we have phones now. I made this trip. I made this trip with a folding map. Now check it. And I got stuck too because I got the needles, and I was like, oh, thank goodness. There wouldn't be a gas station in Arizona from this point. So we stopped the needles and we got gas. We went across the Arizona border. And I was like, that's $1 cheaper here. I feel pretty bad. Okay. We have to find the parabola, right? And this is a parabola because we have an x squared. It's facing down. So regardless of what else we're dealing with here, okay, we're looking like that. So we want this point up here to get our optimal, to get our best, our maximum, right? This will be our maximum speed for our, well, this will be the speed for our maximum gas mileage. This is miles per gallon here. Okay. So this is a formula you do have to memorize. I'm sorry. But the vertex is found where x is equal to negative b over 2a. All right. Again, I remember having to memorize this formula. I resented it because you're going to learn another formula in calculus, but it'll help. It'll help build that connection. So I don't mean to do that to you, but it really does get a little bit better. Okay. So there we go, right? We have negative, there's our b, negative 2.666 from the negative here. And then a is going to be 2 times this thing right here. Okay, let's go ahead. Check this out. So 2, and the negative over negative, right, that's going to cancel. So 3 sixes divided by, this is 2 times 0.037. Okay. Wow, that's not, those are crummy cars, what this is. So x is equal to 36.02 some, so we're going to say 36 miles per hour. Okay. All right. I think somebody fabricated some data here. It's usually like 45 or 55. It's almost never down to this far. Okay, gas is at maximum when the car travels at 36 miles per hour. Now, the next part, part B, they don't have it on here, but they're going to say, well, you've found that it travels best at 36 miles per hour. What is the gas mileage at that point? Okay, so we're going to take this 36, we're going to plug it back into our formula, right? We're going to do that. So negative 0.033, we're going to have 36 squared here, plus 2.666 times 36 minus 35.026. Okay, oops, there we go. Let's see here. So we have negative, remember to get the right negative, 0.033 times 36 squared plus 2.666 times 36 minus 35.026. Hope for the best. Crossed fingers. I don't like that answer. Not one little bit. Let's see. What did I screw up? Oh, you know what I screwed up? It's not 0.66, it's 0.63. Times 36 squared plus 2, because having a negative gas mileage, right? That wouldn't make any sense at all, no matter what speed you're going. If I go slow enough, I'll put extra gas in my car. It doesn't work that way. I wish. There you go. Both messed up. What should have been a times here? That just doesn't look right to me. It's like, wow, that's 36 squared. Okay. Plus 2.666. So I won't say that these are necessarily like entirely fabricated, but they're at least approximating to reality. So if you get ridiculous answers like that, you should know, like, wait a minute, I don't have a car that has 61 miles per gallon. 18 miles per gallon, that's a reasonable gas mileage. I could believe it. All right. I have gotten in arguments with people about that, though. I'm telling you, truck gets 60 miles to the gallon. I don't think they're calculating that right. Whatever. All right, that's a good question. I like this one. Let's see here. Oh, let's go back. 13. Okay. All right. All right. I like doing these backwards now. I don't like doing them this way. I like telling you some things about the function and then have you tell me what the formula is or something like that. So we're going to say construct the polynomial. Given conditions. Okay. So let's see here. Assume everything is represented in the graph. So what do we have here? We have 1, 2, 3 turning points. We have 3 turning points, which means we have a degree for a polynomial. Right? Think about this. If you have 1 turning point, what kind of a graph is that? It's quadratic, right? You have 1 turning point, you end up with second degree. Okay, you should know what a cubic looks like, just a basic cubic. Something like that. We have 1, 2 turning points, 2 turning points. Goes to a cubic. Okay, so 3 turning points, 3 plus 1 would be 4. We have a fourth degree polynomial here. Okay, so turning points plus 1, that's your minimum degree. Okay. Okay, so we know it's a fourth degree polynomial. Well, it may be more, but minimum degree is 4. Okay. Determine, I'm not going to ask you quite this many. Determine if the leading coefficient is positive or negative. It's facing up, so it's positive. Okay. And is the polynomial, the degree of the polynomial is odd or even. 4 is an even number. Okay. It's not symmetric, so this polynomial is not even or odd as far as polynomials go, because it's not symmetric about the origin or the y-axis. Okay. Number of zeros, 1, 2, 3. Okay, that's it. And are there multiplicities even or odd? Well, this one breaks through, so that's odd. Breaks through, it's odd. This one bounces, it's even. Okay, so we have an odd, even, odd. So 1, 2, 1. Again, fourth degree polynomial. Okay. Should probably find some more of those, something like that. Oh, good job. Okay, let's see. Vertical asymptotes, horizontal asymptotes, y-hairs. Oh, this is great. Look at all of this. I can ask. Okay. So what do we have here? We have 5x minus 9. All right. So X-Intercepts. So that's when, right, y is equal to 0. So we're going to set this equal to y. So I set this equal to 0. 5x minus 9, x squared minus 25, set it equal to 0. Okay, so one of the things that we do in intermediate algebra is we have a whole chapter dedicated to doing problems like this. And it's unnecessarily difficult. It's unnecessarily long because the first thing you're going to do to solve a rational expression like this or a rational equation like this is you're going to multiply both sides by the denominator to make it into something that is not a rational equation. Okay, so the last thing you want to deal with is a fraction. So the first thing I'm going to do here is I'm going to say 5x minus 9 over x squared minus 25 times x squared minus 25 is equal to 0 times x squared minus 25. Okay, cancels that. We have 5x minus 9 is equal to 0. I'd like to say problem solved. Not quite. We still have some more work to do. And this is just finding the intercept. 5x equals 9. X equals 5/9. Okay, there's our intercept. Okay. But that is really the whole thing with intermediate algebra, well, not intermediate algebra always, but like one of the big things is when you have to solve rational equations, first step, turn it into something that is not a rational equation. Okay, multiply by the fractions and get rid of them. Okay, after that, we have some other problems. What are the vertical asymptotes? So that is x squared minus 25 is equal to 0. X minus 5, x plus 5 equals 0. It's always safer to do it this way than it is to do other methods because you're not losing information. But you could have put this on the other side and used square root principle. Okay, that would have been fine as an answer. All right, but those are your steps either way. So, vertical asymptotes. 5, x equals negative 5. Okay. Horizontal asymptote. Okay, this one's, you guys are going to enjoy this. Horizontal asymptote. Well, what's the degree of the top? Degree of the top is 1. What's the degree of the bottom? That's 2. The top has a smaller degree than the bottom, therefore your asymptote, horizontal asymptote, y equals 0. If they were the same, we would take the coefficient, right? We would make the asymptote a ratio of the two coefficients that we'd have here. Okay, not the degree, the number in front of it. So in this case, right, if we had an x squared on the top, it would be 5 over 1. Okay. Identify the y-intercept. Ah, this one's a nice one. Okay, y-intercept. Well, set x equal to 0 and have at it. So that is going to be negative 9 over negative 25, 9/25. So we have 0, 9/25. Okay, a little less than half, right? Because 12/25 would be about half-ish, smaller than that. Okay, and they want us to, they're probably going to want us to graph that, right? Oh, no, they didn't. Boring. Okay, well, oops. So we would type all this stuff in or box it, right, for our answer, and then be done with it. By the way, slant, oblique, please, oblique, not slant. You have one or the other. You don't have both. Okay, you're not going to see both in a class like this. Okay, so it's possible I could put some kind of horrible piecewise function together. We could have a horizontal, we could have an oblique asymptote and a right, something like that. Or we have, you know, two asymptotes going like that. Not going to see it in this class. So if you're looking at this, like, oh, that could happen. No, I mean, it could, but we're not doing that. All right, not happening. All right, why don't we stop here for the evening and continue with our quest to find good final exam problems tomorrow. Okay, so far, definitely a circle problem. Given 2 points, make a line, difference quotient, quadratic. Function composition, it won't be like nuts with finding a domain. Okay, we'll keep it simple like we had here, which I'm underselling it. When I say keep it simple, it really wasn't that simple. Okay, but it could be a lot worse. Word problem with quadratic, perfect. And construct a polynomial for given conditions, and all we're going to put in. Describe rational function. Okay. Kind of like what we did over there. I might decide to make you guys graph it. I might sell it to you the other way, but something like that. Okay. So let me go ahead and stop recording because that's a long